All right, so 11.3, number 5. So the trick with this one is it deals with a cart that's rolling. All right? And what the problem tells us is it says, all right, you've got this cart that has 4 wheels on it. All right? It tells you that the total mass, so the mass of the cart and wheels combined, is 1 kilogram. Okay? It tells you that the mass of just the wheels by themselves is 0.1 kilograms, but there are 4 of them, right? So the 4 wheels combined is 0.4 kilograms. Okay? And so our cart's going to be rolling down a hill. Okay? So the trick is this, that when we're looking at the total energy at any given instant, so here's my cart, right? So if I'm looking at the total energy of my cart, do you guys agree that when I look at the height, like the whole cart has height, therefore the whole cart is going to have GPE, right? Okay? So the total energy is going to be equal to the GPE of the cart plus the wheels, right? Plus the kinetic energy. Let's see. So if it's moving, what's got kinetic energy? The cart and the wheels. They're all moving together, right? So I'm going to have kinetic energy for the cart and the wheels. And there's rotational kinetic energy. But just the wheels have the rotational kinetic energy, right? Because just the wheels are spinning. Follow? Okay, so I'm not ignoring you. Does everybody see what I'm getting at there? Okay, Weston and then AJ.
I asked you on the lab, and I think I asked something like, why is a cart rolling? And you said we just ignore RKE, so I ignored
Gotcha.
RKE's problem.
Yeah.
Am I not, like for future references?
So if it explicitly gives you the mass of the wheels, it's implying that it's important.
Okay.
Okay. The idea is these carts. Sorry, guys, I don't know what's going on with my shoulder. These carts. This is about a pound. Okay, it's like half a kilogram, so it's about a pound. But these wheels are tiny little plastic things. So technically speaking, they do have mass. But like here, I mean, look at this is 40% of the total mass, right?
Yeah.
So it's a pretty significant chunk. But here it's going to be, maybe 1%.
Okay.
Does that make sense?
Okay. I just wanted to, yeah, because I first to the problem and I'm like, oh.
Right. I gotcha. That makes perfect sense.
Okay.
So, but do you guys understand why I was able to say that the RKE here is more or less insignificant, but we can't do that here? All right. And if you're unsure if it gives you the mass of the wheels, then you should assume that that's important. You know what I mean? Okay. AJ?
So 2 questions. One.
Nice. I dropped that. Okay. 2 questions. What do you got?
Okay. So I'm understanding what the W means wheels. So what does the C mean?
I guess it would mean the cart, but not counting the wheels, like the body of the cart.
Oh, okay. And this is my second question. This is kind of like stupid.
No, you're fine.
Would you consider this cart like a 4-wheel drive, like all of them, like how they call them?
Well, all of the wheels are rolling. When I think of 2-wheel drive or 4-wheel drive, I think of like an engine making the wheels go, and there's no engine here. It's just rolling. You know what I mean? So like a skateboard. You know what I mean? A skateboard, it's not 4-wheel drive. You know what I mean?
Yeah.
It's just coasting. So, but yes, all 4 wheels are rolling.
Okay, this is dumb questions.
No, you're okay. All right, so does everybody understand what I'm getting at here? All right, so then the question is, how am I going to deal with this rotational kinetic energy of the wheels? Well, the rotational kinetic energy of the wheels should just be equal to the kinetic energy of the wheels times B. And I think it tells you the wheels, or the shape of the wheels, right? This is not the right piece of paper. Does it say the wheels are a hoop? What does it say? Let's see. The wheels can be treated as uniform disks. So a uniform disk is 1/2 mr squared. So there's my B. Does that make sense, you guys, or no? Okay, so let's see. So we're rolling. The cart is placed at the top of a 3-meter long ramp inclined at 30 degrees. When I give you the length of the ramp, you guys, that's the hypotenuse. And when I tell you the angle that it's inclined at, that's always off the horizontal. So that means this side here is going to be 1.5, right? Cool? So, let's put this over here. Okay, so total energy at the top has got to equal the total energy at the bottom, right? So at the top, what kind of energy we got? GPE, right? So let's see, the mass, how much mass has GPE, you guys?
All of it.
Yeah, all of it. So 1 kilogram times 9.8 times 1.5 meters equals, follow or no?
Yeah.
That's the total energy at the top, right? We're trying to find the velocity at the bottom, right?
So the kinetic energy.
Yeah, so at the bottom we've got kinetic energy and rotational kinetic energy. So the kinetic energy is 1/2. So for regular kinetic energy, we want cart and wheels, right? So that's 1 kilogram times v squared plus the RKE of the wheels, right? And we decided that was just B times the kinetic energy of the wheels. So again, what's B? So let's see. So we want 1/2 times, now we need to write an expression for the kinetic energy of the wheels. Well, kinetic energy is 1/2. What's the mass of the wheels? 0.4 times, oh, v squared again. And there's your equation. You just solve that mess. I say just, like it's trivial, but that's how you do it. Question? You good?
Yeah, I was trying to write in low.
Gotcha. Did I do that too quick?
No.
Cool, you guys? Holly, does that make sense? You were asking about that before
Wait,
class.
so, okay. Is the, what's with the red, stuff in red?
Nothing, I just was,
Okay.
yeah, there's no significance to the class. I was just sort of separating the types of energy. What's wrong?
I'm just kind of confused.
Your hair's doing some riding today, by the way. It's cool. I'm a little jealous of
Oh, I got to school
You get-
7 minutes, well, not 7 minutes before the bell rang, but like I woke up 7 minutes before the bell rang, so.
it. It's sweet.
Oh, okay, thanks.
You're welcome. Okay, you were going to ask me a thing that was not about your hair.
Oh yeah, so I'm kind of confused, like, about like how you plugged in those like numbers.
Where I got all those numbers from?
Yeah.
Okay, so what's written in blue here, well, okay, so let's take it one piece at a time. So this is the GPE of the cart and wheels and everything at the top of the hill.
Yeah.
That's what's in red. Are you good with that?
Yep.
Okay, then as it goes down the hill, you lose GPE, and by the time you get to the bottom, the GPE is 0, right?
Yeah.
So that means when you get to the bottom, all of my energy is now kinetic from motion, linear motion,
Yeah.
and rotational kinetic energy from
Oh.
things that are spinning.
Okay, I forgot to like include the RKE.
Gotcha. So we got to do that. So here's the kinetic energy of the whole cart. Notice the mass of the cart and the wheels combined is 1 kilogram. So that's the mass I used there, right?
Yep.
But when you find the rotational kinetic energy, which is what's here in green, it's B, because it's 1/2 for a solid disk, times the kinetic energy of the wheels. And notice the mass that I used there is just the 0.4, right?
Okay. So how would you plug that in for like the equation that's 1 plus B?
Gotcha. So if you,
Or is it just easier to do it this way?
no, you can do it that way too. So if you did it that way, well, here. So let me solve this. So if you solve all this, you get 14.7 equals 1/2 v squared, so that's 0.5, and this is 0.1, so you get 0.6 v squared, and then solve that. Okay. Now, if you want to do it the other way, let's see what that would look like. So total energy at the top equals total energy at the bottom. So my total energy at the top is still going to be the same. Or the total energy at the bottom, which is, I wish I knew my 50s music better. Okay, you good with that?
Yep.
All right, so now, if you want to go the TKE route, then, so when we do TKE, we're implying that there's both kinetic energy and rotational kinetic energy, right?
Yep.
So, I could do the, again, no significance to the colors I'm using. So this would be the total kinetic energy of, so what part of the car has total kinetic energy? In other words, what part of the car has both KE and RKE?
Oh, the wheels.
Just the wheels, right? Plus, so all I've counted there is the total kinetic energy of the wheels.
Oh.
But I'd also have to add in the kinetic energy of just the body of the cart. You see what I mean?
Yeah.
So that would be, so this blue part would be 1 plus B times the kinetic energy of the wheels. What's the mass of the wheels again?
The mass is, wait, 0.4?
Yep, 0.4 times V squared, right?
Oh,
So
wait.
there I've accounted
Oh,
for,
Wait. Oh, yeah, total, yeah.
right? 4 wheels, 4 times 0.1. So here I've accounted for the rotational kinetic energy of the wheels and the kinetic energy of the wheels, right? But I haven't dealt with the body of the cart at all. So now I got to deal with that. So plus the kinetic energy of the cart. Let's see, 1/2 times, now you got to be careful. What mass would I use? What mass have I?
Oh. So you have to subtract the 1 kilogram.
Exactly.
Like,
So 1
0.4,
minus
yeah.
0.4, so that gives you 0.6 V squared. And solve that, and it'll give you the same answer. Follow?
Yeah, that makes sense.
What you can't do is use 1 kilogram here, because then you'd be counting the kinetic energy of the wheels twice. Once
Okay.
here and once here.
Yeah, that makes sense.
Cool?
Thank you.
So basically it boils down to just figuring out what components have what type of energy and make sure you account for all of it. Cool? Okay. So that is that. I'm going to stop recording now. And when does the bell ring? Like in a minute? You guys.